Let me just go through very, very quickly, like the main misconceptions, because this is actually also going to be loaded up as well. So I'm going to go through the main misconceptions, right? You can actually see the total points distribution. Everyone did very, very well. There's only, I think, one person who kind of tailed off. One person who tailed off. Okay, you can see that. This is actually a topic that people can do successfully, and it's then a case of you've got to be able to remember the facts on the day. Okay, especially when you get asked those questions, right? So let's just have a quick, brief look at where the mistakes were. Okay. The flame test. Flame test, there's only one person. You can see that one person may have just rushed through it. First question, every single other person got it right. 47 people got it right. Lithium for red, lilac, potassium, orange yellow for sodium, copper was green. See that one person just getting all of the flame bits wrong. So I think they didn't really look at the colors, did they? Right, okay. So where you had the first bit of difficulty, so you had a little bit of difficulty with the dilute nitric acid, adding silver nitrate, white precipitate form. That's a chloride test. Okay, it's a chloride ion test. So you can see that causes a little bit of difficulty. Okay, the reason why I'm going through this part is when I go to your answers, I'm going to then show you that you're not the only person that got it wrong if you got it wrong. Okay, or if you are the only person that got it wrong, then you need to get it right, obviously, right? And if you're not getting it right, you might be confusing it with one other common misconception. So you can see over here that many people confuse the chloride test with the sulfate test. Okay, chloride test and sulfate test are very, very similar when you watch them, when you see them, but you can actually get the right answer if you think about the reagent. So if you know that the reagents are nitric acid, it has to be acidified silver nitrate, and you use acidified silver nitrate because just in case there's carbonate ions or anything else in the sample that you're testing, if you have, say, for example, a carbonate ion, which is a common ion that's contained in solution, that will give you what's called a false reading. Okay, so it will suddenly go white, and you'll think, oh, there's a chloride in there, and there may not necessarily be a chloride in there. Okay, so you have the acid in there, and it's nitrate because silver nitrates are completely soluble. Okay, they're completely soluble and they form a colorless solution. That's the reason why we did all that solubility work previously. The next one, silver nitrate. So more people getting the bromide and the iodide correct than the chloride, which was curious. So the chloride one is the one where people instinctively put sulfate, but as soon as yellow precipitate and cream precipitate is asked for, it suddenly focuses their mind. Yeah, can you see that? Yeah, suddenly focuses their mind. So that's a really interesting one. So if you do see a white precipitate, just be cautious. Okay, just be cautious. All right. Carbonate ion seems to be very successfully done, and for the one that I don't know whether that's like an anomaly or whether that person just decided to select random answers, right? But I can see, I think if there was a mistake that was done with carbonate, I would think that they would click sulfate or chloride because they would see white precipitate. Okay, all right. But virtually everyone got carbonate right. 98% of people actually got carbonate. Okay. Right, the next one, nitrate seemed to cause quite a bit of a stir, okay? But nitrates test is a very unique test, okay? Small pieces of aluminium, sometimes you can have just powdered aluminium, heat gently. If ammonia gas is given off, the unknown substance contains nitrate ions. Now look at what the makeup is of the actual ion on the right-hand side. So ammonia would come from a nitrogen-containing compound, okay? And the only anion, negative ion, that contains nitrogen that you have to cover is the nitrate ion. So use that information, use that information in order to help you. That's the tip that I would give you if you got the nitrate one wrong. Okay, if you're getting the nitrate one wrong, or if you're forgetting the nitrate. Okay, if you're not getting that too easily, try and think with the nitrate one, what are the ions that I have to learn about, and which one's the only one that has nitrogen in? Okay, you got me, guys? Yes, got me, guys? Abhishek, you falling asleep?
No.
No? Yes, right, get off your phone, yeah? See? Mohammed, yeah? He's on it, yeah? Put your phone off, Abhishek, yeah? Lol, oh, look, bright red. Caught it red-handed, didn't I, Sam? Barium sulfate is insoluble, okay? Barium sulfate is insoluble, okay? And it would not make sense. It would not make sense if you are adding dilute hydrochloric acid and then suddenly coming up with a positive test for chloride ions. Why would it, Abhishek, why would it not make sense? Why would it not make sense to select chloride ions?
Because hydrochloric acid contains chlorides.
Correct. Okay. So as soon as you add the dilute hydrochloric acid, you're immediately setting off you're setting up a false reading. Okay. If you are thinking that chloride ions are tested using hydrochloric acid and barium nitrate. Now, the reason why you have hydrochloric acid in there and not sulfuric acid is because if you added sulfuric acid, what would happen? Who can I ask? Who would like to take this one? Hazard a guess. Come on, guys. Sulfuric acid, right? It's a test of sulfates. Why is it not sensible to add sulfuric acid? We have to think about this. Why? Seb, what do you think? Sorry, Seb. What do you think?
Because if you're testing for sulfate ions, then it's gonna give an incorrect reading because there obviously will be sulfate ions in sulfuric acid.
Hey, look at that. Brilliant. Okay, brilliant. So what I'm doing, guys, for the rest of you, right, that's a great answer. What I'm doing is I'm trying to link this with our previous learning on acids. Okay, so when we were doing acids, we thought about hydrochloric acid and how it dissociates. We were concentrating on the proton being lost. Okay, now I'm looking at the other ion, which often formed like a spectator ion in your acid-base reactions. Okay, so that's the reason why I'm going back over this, just to remind you of previous work. And there are links in chemistry. There are links that you can make between areas. Okay, good answer, Seb. Well done. Bravo. Full amount of dilute hydrochloric acid. Heat the mixture gently. Choking gas is given off. Filter paper. Right at the top, it decolorizes it, okay? That's a very unique test. That would be the sulfite ion, okay? If you add a little dilute sodium hydroxide solution, heat gently, ammonia gas is given off. Just make sure that you're not confusing that with the nitrate test, but this is testing now for positively charged cations. So again, the only one that has nitrogen in that you have to know is the ammonium ion, okay? The ammonium ion. So a couple of people saying copper, iron, calcium, chromium, but the only one that contains nitrogen, which is in ammonia is NH3, the only one that contains nitrogen that you need to know is the ammonium ion, okay? And this is the positive ions that we're testing for now, okay? Virtually everyone got copper 2 right. Look at that, 100%, okay? Pale green precipitate, that's being confused with chromium, and the reason why is because they're confusing it with green, but the precipitate comes from iron 2. With chromium 3, you form a green solution, okay? A green solution. You do not form a precipitate, okay? So iron tends to give mucky precipitates. All right, iron 3 is red-brown precipitate. Some people confusing it with iron 2. There's two different flavors, two different types of iron. So we're going to be talking about oxidation states later in the course, okay? But there are two different flavors. This one caused the biggest upset, okay? Aluminium. It's a very unfamiliar test. So sodium hydroxide or ammonia. So you're basically a base. White precipitate forms, it dissolves again on adding excess sodium hydroxide. Now, the reason why this occurred was because the aluminium compound is amphoteric, okay? And when we covered acidic oxides and basic oxides, there was a little tiny section on amphoteric oxides. The good news is that you don't need to memorize that negative ion. You don't need to memorize the formula. The only thing that you need to remember is if it's a white precipitate and when you add excess sodium hydroxide, so you're introducing more OH minus ions, what happens is they latch onto the aluminium and they turn it into a negative ion, which can then redissolve. That's basically the chemistry behind that. So you can see that that's quite confusing for people. Okay, but you've also got to remember that it will not dissolve if more ammonia is added instead. Okay, whereas the zinc one will dissolve. So that's how you tell the difference between those two ions. That's a very, very cute bit of chemistry there that's happening. The reason why, because it doesn't seem to make sense, but aluminium is a very small ion, okay? Whereas zinc is a very large ion, okay? And so the only thing that the aluminiums can pair up with are tiny hydroxide ions. Compared to that, the ammonia molecule, which will attach itself to the zinc, that ammonia will attach itself to the zinc. The ammonia is too big and it bunches around the aluminium ion in an unfavorable way. So that's the reason why. It's not just a random fact. Now, am I expecting you to come up with that stuff? No. But I wanted to try and justify that. There is actually sense behind this. And the scope of that, if you're really interested in stuff like that, that's where A-level chemistry comes in. So you actually unlock all of the answers. So the questions that are never answered in GCSE. Okay. All right. So that's the only one. But just for now, just think, right, okay, ammonia, it will not dissolve the aluminium. Okay, it's just a memory thing. And we're not allowed to tell you, it's confidential. Okay, and then finally, watch this one. If there's no precipitate or a slight amount of precipitate, which is white, that comes up with calcium. So it's the same test. So if it's no precipitate or very slightly precipitate and very, very milky, it's going to be calcium. Okay, if it's a precipitate and it's a very strong precipitate, but it redissolves with ammonia, you've got a zinc 2+ ion there. Sorry? Yeah, that's right. But if it does not redissolve in ammonia, you've got the aluminium. Okay, so that's the key with that one. And then finally, a grey-green precipitate forms. It dissolves again if you add more ammonia, giving a purple solution. So I think earlier, there we go. A grey-green precipitate forms. It will dissolve on adding excess sodium hydroxide. There's that green solution I highlighted. And then what happens is you form, the chemistry behind this is very, very intricate. You add more ammonia, so it's a really strong alkali solution. Then you get another green precipitate, but if you add more ammonia, it goes purple. That is the chromium test. And guess what week we covered this in? Rashid, just give me a number. What week of this? 5. It was earlier than that. Mohammed. Mohammed, we've missed you. Don't worry, it's not as if this is being uploaded on YouTube or anything. Okay, right. Rashid gave 5, and I said it's earlier than that, and you just said 5.
3.
3. It was actually earlier than that. Okay, Abhishek, what do you think?
2.
2, roughly. Okay, finishing off. Rashid's disappeared. So I'll go to. Has Rashid disappeared? Yeah, Rashid disappeared. So I'll go straight to Seb. Rashid, when you're ready, put the camera on, please. Okay. Rashid, can you stop fiddling around with the microphone, please? Just switch the microphone off. Yeah. Rashid, leave the camera. Rashid, leave the camera. Rashid, leave the camera. Leave the camera. Leave the camera, because you're really messing up my presentation. Okay, every single time you fiddle about with a camera, the microphone sets off, and then no one can hear me. That's right, guys, isn't it? Yeah. Yeah. Just leave it. Allow it, as we say. Yeah, just allow it. All right, allow it. What do we say, Mohammed?
Allow.
Allow it. Yeah, just listen to Mohammed. Thank you.